All right, CNT140, we're on the fiber optic book, Chapter 1. We just got done talking about the different types of fiber, aerial, buried conduit, etc. So with these, the fiber itself is optimized for that application. So with the fiber pulled through conduit, it is optimized for tension and resisting moisture as it's in there. Buried cable is designed to resist moisture as well as rodent damage. Aerial, designed for continuous tension and extreme weather, all the elements that are out there, ice and wind and sun and so forth. Undersea for resisting moisture and also the pressure of the water on the cable. With these different types of fiber, there's often special types of equipment that are used to install it. So as you're dealing through conduit through utility lines and conduit underground, there's often cable pullers and cable pulling equipment that's used to pull that cable through the conduits. There's also cabling that can be blown through as well. I think we mentioned air blown fiber earlier this semester. So you can actually blow fiber through the cable, fiber cable through the conduits, but you need some equipment to do that as well. If you're burying, you might actually be using a plow or other type of trenching equipment, if you will, to put the fiber in. If you're doing aerial, you're going to have bucket trucks and again cable pullers and spools of cable that you'll be using to get the fiber up onto the poles and into the hooks and so forth and pulleys on the poles. If I'm doing submarine cabling, there's obviously special boats to hold the cable and lay the cable carefully on the ocean floor, or using a plow on the ocean floor to kind of like trench and place the cable on the ocean floor as well. Long distances mean cables are spliced together at some point or another. Fiber is only usually made in spools of a few miles long. So any long fiber optic cable connecting city to city is going to need to be spliced periodically. And that is done by fusion splicing. Fusion splicing, you're actually taking the two fibers and heating the ends up and touching them together while they're perfectly aligned and allowing it to cool, and those two are now joined, almost like taking two garden hoses, putting them together with a good connection and tape, if you will. That's what the fusion splicer is doing. Connectors, terminations, or connectors for fiber, many of them in the past were either epoxied on or crimped on. Most of the modern ones are actually spliced onto the fiber. Either the connector is spliced on or the fiber is spliced onto a pigtail that's on the pre-terminated fiber, one of the two. After it's tested or after it's installed, it'll need to be tested for any signal loss. You're trying to get practically zero signal loss through those connections, through those terminations, through those splices. Outside plant fiber optic installers usually have bucket trucks that they're going to be using, to get cabling up on poles and so forth, and also climate-controlled vans for pulling the fiber and doing the splicing, doing the connections, doing the terminations, and so forth. Again, dirt is the key challenge when dealing with all this. So a climate-controlled van where you can control the cleanliness is helpful. Most outside plant installs are done by the telecommunication companies themselves. But there are some installers that will do, like cable TV and so forth, installers that will do it for smaller jobs, that sort of thing. But a lot of times it's actually the telco provider that's doing those installs. Premise cabling installed in a building. This is the stuff we've been talking about so far this semester. The backbone connections between closets, it's typically a few hundred meters long, and it's typically going to be multi-mode fiber, and I'm going to have a handful of strands, 6, 8, 10 kind of strands going from closet to closet. So a lot less distance, a lot less strands, and typically multi-mode fiber connecting closets. And again, we're talking about the fiber here connecting main closet to the closet out on the floor. My drawings from before, your main closet here, fiber connection going up through the floor to the closet above. Again, fiber optic going from this closet up through the floor to this closet above it. That's what you're typically going to find in your premise cabling. Splicing is not typically done in premise cabling because of the short distances. The cabling can be actually ordered, 283 meters long with connectors on the end. So the need to splice is pretty low. It's not very common. A lot of if you are making interconnections, are usually done with a patch panel. You basically plug the connector on one side of the patch panel and the connector of the other fiber on the other side of the patch panel, and that makes a practically zero loss connection between those two. Most of the connectors you're going to encounter are a CST or LC. Most of the modern connections are going to be LC, but for a while ST was common, then SC was very common. That was very common for a long while. Right now LC is very common. That's the type of connection you would typically find connecting two switches together. Your premise cable installer will be most likely doing the copper, but might actually be doing some of the fiber connections between closets and so forth. And they're going to have, as they say in here, small fortune in tools and testers to do so. Yep. So they'll probably be able to do both of those for you. Now, very few installers do inside and outside. Typically, they're going to do one or the other. Your outside plant is typically just going to be doing those connections, utility poles, that sort of thing. Your cable installer that's doing the copper in the building would also do most likely do the necessary fiber connections between your closets. And they say down here most contractors do nothing but premise cabling. Yeah. One of the biggest advantages of optical fiber is cost-effective means of transporting information. And this was actually a picture from back in the 70s. This was showing a multi-pair phone line that would be used to connect, two main phone providers together, and all that's getting replaced by this single strand of fiber. That was one of the big advertising pictures back then. The bandwidth and distance capability means fewer cables needed, fewer repeaters, less closets, those sorts of things, less power, and less maintenance for all that. Fiber itself is unaffected by your electromagnetic interference, and the electromagnetic fields around power cables and so forth, unaffected. Fiber is lighter than copper wires, which makes it popular in certain applications. They talk about aircrafts, automotives, that sort of thing. Yep, makes it popular in those applications in addition to the data applications we're talking about. Wireless was used as a long-distance medium until fiber came along. Wireless is kind of limited by the available frequencies. With fiber, a lot more bandwidth, and you have a lot of connections of fiber from the cellular towers back to the switching office. While local wireless is growing exponentially, it uses fiber as the backbone in your data network, which we know. Between your data closets, they're typically going to be a fiber connection. Initially, when fiber optic came out, it was people that were highly trained, highly specialized that needed to work with installing fiber. Now, most of your contractors, there are people trained to be able to install the fiber optic and terminate and work on it and so forth. So again, most installers will do the copper as well as fiber. Fiber still has plenty of headroom, meaning if we're using 10 gig of it now, there's still plenty of more bandwidth capability in that fiber. So installing a good quality fiber now, you might actually be able to withstand 3 or 4 or 5 upgrades on that fiber without having to replace it. So here they talk about, isn't it more expensive? Well, initially it was. Now the price has come down, and with these advantages, yes, you have a little bit of cost up front, but these advantages pay off in the long run. And that's when they talk about the centralized fiber that we mentioned back earlier this semester. Following the standard, we can do a centralized fiber install that will handle a lot more bandwidth out to the high bandwidth needs or users in the facility. Reminding us about the standards. The standards were really developed to ensure product compatibility. The standards aren't codes, but they're kind of the logical, if I follow these, things should be compatible and working. And we hopefully remember the EIA, TIA, and IEEE in the US, and ISO for international for our standards. Our standards we follow, or the standards we've been following for cabling installs are 568, install the premise cabling network. and they remind us about, in the U.S. here, we have the NIST, National Institute of Standards and Technology, that sets any sort of optical power measurements and those sorts of things on our fiber, our test standards and so forth. We should also remember that the actual codes we need to follow are from the National Electrical Code. Your National Electrical Code has in there, this is your building electrical codes, what should be done and what should not be done. And here is, as we look across the National Electrical Code, there are sections on optical fibers as well as our LAN cabling and install that we have talked about earlier this semester. Standards also call for your fire retardance of your cabling that you're installing. So do remember the general riser plenum rating on fiber optic cable. As I look at the jacket, if I look at that last letter, OFNR for riser, that'll let you know that cable can be installed between floors, between closets and between floors. And then here this actually says plenum or OFNP. Here's an OFNR, a riser. Here is an OFNP for plenum. That could be installed in a plenum space above ceilings and so forth. We should hopefully remember these standards with, your structured cabling, your closet pathways and spaces, residential, your documentation, grounding and bonding. All of these have things that we should be following to help make sure everything is functional and functioning the way it should. International standards equivalent. Again, hopefully we should remember that from earlier this semester. When dealing with fiber optic, we have some safety we need to pay attention to. The light sources for fiber optic are generally low power level. They're not lasers that are designed to cut through cans and that sort of thing. However, they are at wavelengths that can do damage, and there are wavelengths that we usually can't see. So with that, I do need to be careful about where this light is going. I never want to look into a fiber unless I know it is disconnected and there's no light source on the other end of it. So I do need to do some caution there. One of the real safety concerns with fiber optic is the scraps of glass fiber that are getting cleaved off. That glass stub is very sharp, and it actually would be a very sharp, clear splinter that's hard to see. It'll penetrate your skin easily, and it's hard to see to be able to get out. So they remind us about wearing safety glasses, and always have a way to dispose of these fiber scraps carefully in our work area. And then here are some reminders about working with fiber: wearing the safety glasses, dispose of your scraps, don't drop anything on the floor, and carpets and so forth. Don't work over carpets and so forth with those. And then don't eat or drink anywhere near, because you might actually ingest a fiber stub, which you don't want to do. Dirt is one of the main culprits of fiber optic connector loss, so we need to make sure we're working in a clean environment, keeping dust caps and things on. And as I'm working with a fiber, I want to remember what we talked about earlier this semester about cleaning fiber connectors, cleaning the fiber connectors before we make connections. So here's some reminders again about keeping the work area clean, dust caps, use your cleaners, those sorts of things. And again, here's a reminder about cleaning your fiber optic connectors before you plug them in, or even cleaning your fiber optic ports on testers and so forth that you're using. Clean those before you make any connections. So there's chapter 1 of our fiber optic book.